Right now I want to talk about how to convert a polar equation to rectangular form. We'll start with the example, and then we'll explain what we're doing as we go through. So if we have a polar equation, r equals 2 over 1 plus cosine theta. Keep in mind that our polar coordinates consist of a radius and an angle. And in this problem, our angle is a function of our radius. It's no different than y equals some function of x in rectangular form. In fact, what we're going to do here is we're going to convert this equation into rectangular form and express it as a y as a function of x. It helps to understand what we're doing if we were to sketch out a little graph and understand the relationships between radius and angle and x and y rectangular coordinates. If this is our polar coordinate, it is formed by a radius and an angle. So in order to get the rectangular coordinate, we would look at a different type of system in which we looked at the distance along the x-axis compared to the distance along the y-axis that corresponded with our given point. So if we understand that this is our y and this is our x, we can now look at the relationships using our trigonometric relationships to understand how all these are related. For example, if we wanted to find y out of all this, looking at our polar coordinates, y, what's the relationship of y to our angle? Remember the trig functions, the sine of theta is equal to opposite over hypotenuse. So sine y is equal to y over r. I'm sorry, not sine y, sine theta, I'm sorry, thank you. Sine theta is equal to y over r. If we were to multiply r on both sides, that makes y equal r sine theta. Similarly, for the x value, cosine theta is equal to x over r, and that would mean that x would equal r cosine theta. Well, now we see how to find x and y. How would we find r and theta if we knew what x and y were? Well, you'd use the same relationships. You can use your trigonometric relationships, or you can use Pythagorean theorem. R squared is equal to x squared plus y squared, which leads us to r equals the square root of x squared plus y squared. Well, how do we use these values in our equation up here? If we were to multiply both sides of this equation by 1 plus cosine theta, that gets all of our values out of the denominator. So if I were to multiply by 1 plus cosine theta times 1 plus cosine theta on both sides, we now have r times 1 plus cosine theta equals 2. And now it's just a matter of the distributive property, r plus r cosine theta equals 2. And now we should be able to recognize some things here. R cosine theta, what's that equal to? Well, this is just going to be x. R square root of x squared plus y squared. And we've now essentially converted this into an equation that no longer has a radius and angle, but x and y coordinates. Now there's some different ways that you can manipulate this mathematically. If we want to get rid of the square roots in the problem, for example, we could subtract x from both sides. So minus x, we'd have the square root x squared plus y squared is equal to negative x plus 2. And now to get rid of the square root, we would square both sides. X squared plus y squared equals, and now we have a binomial squared, so it's the a squared plus 2ab plus b squared scenario. Negative x squared is x squared plus minus 4x plus negative 4x, because negative x times 2 is negative 2x times 2 is negative 4x plus 4. And simplifying this, subtracting x squared from both sides, y squared equals negative 4x plus 4. And that's how we would convert polar equation into a rectangular equation.